All right, Ruofan, please.
Okay, hi everyone, I'm Ruofan. Today I will present my QE report, Inferring Phishing Intention via Webpage Appearance and Dynamics, a deep vision-based approach. My research interest is in AI for cybersecurity. Previously, I have 2 works working on phishing detection. Today, I will introduce my second work, also do a bit cover a bit on my first work. This is the overview of my presentation. I will end my presentation with the introduction of my research framework and future direction. According to last year's Cisco report, phishing is ranked in top 2 cyber threats among all types of cyber threats. At least one person click on a phishing link in around 86% of organizations. Phishing web page is created to mimic legitimate brands, and its goal is to trick users into inputting their credentials. As a phisher, first I will create a phishing website hosted on my own server or compromised server. Then I will distribute the phishing URL via email. Some victims click on the URL and submit their credentials, so their credential will be sent to the phisher and is stolen. Our solution is browser-based. That means we detect phishing web page once it's created, so we can take it down even before it is actually distributed to the user. There are several lines of research in phishing detection. First is blacklist-based solution. Users will report the malicious URL to blacklist provider like OpenFish and PhishTank, and they will keep them. It is quite straightforward and no learning algorithm is needed. However, it's easy to get incomplete and easily outdated blacklist, given that phishing usually have short lifespan. Also, we need somewhere to store all the malicious URLs. Second line of research is classification-based. Researchers tend to craft features based on HTML and URL and build a machine learning classifier to classify it's a phishing or benign. It can be generalized to new URL. However, it's easy to evade. Once the phisher know which features you are using, since they have full control of their source code, it's easy to evade those features. And it's also different from how humans perceive the web page. As a human, we look at visual content. We don't look at source code. Even if 2 web pages have completely different source code, if they're visually similar, we still think they're a similar web page. And the last type of solution is reference-based solution. It's the currently best performing one. The idea is that I will keep a reference list of protected brands, and given a new URL, I will compare it against my reference list. It's more explainable because I can also identify the target brand instead of simply giving a fish or not fish label. They are usually visual-based solutions, so it's more robust to adversarial attack. There's no heavy feature engineering involved. If the features would like to change the visual appearance, that may be noticeable to the victims. There are 4 representative works for reference-based solutions: AMD, PhishZoo, Visual FishNet, and Phishpedia. Phishpedia is our previous work. Before I introduce the details for the 4 work, I will first introduce the skeleton of reference-based solution. So we have a reference repo and a testing URL. First, it will go through a representation extraction algorithm to extract the abstract representation. And then the representation will be matched via a matching algorithm and report the intended target. First work, EMD, they try to extract the color distribution from the screenshot and compare 2 distribution via Earth molar distance. But extracting color distribution is a rather coarse-grained technique. So a more recent work, Visual FishNet, they use a convolutional neural network to encode the screenshot as some low-dimensional embedding and compare them via Euclidean distance. Third work is called PhishZoo. Instead of comparing screenshots, they try to compare logo. Here they use a traditional computer vision technique called SIFT. SIFT will identify the key points in the screenshot as well as in the reference logo and match the key points. However, Swift will report some irrelevant key points, and the key point matching is not very accurate. So in our previous work, Phishpedia, firstly, we use an object detector called faster RCN to precisely report the location of the logo, and we crop the logo and compare logo via SEMIS network. SEMIS network is a deep convolutional network. Given two images, we encode them as two embeddings and compare their similarity using cosine similarity. As you may see, EMD and Visual FishNet are screenshot-based comparison. The advantage is that they consider the web page layout and color design. However, it might introduce additional noises, so it's prone to false positives or false negatives. PayPal is matched to AT&T just because their color design are visually similar. However, if PayPal has a black background, then we may not be matched to PayPal because we don't have similar template in our reference list. Both PhishZoo and Phishpedia are logo-based comparison. They capture the brand intention. However, they also overlook the web page design and is prone to false positive. This web page is reported as an Instagram phishing just because it contains Instagram logo. But as a human, we know it's just some news website. And here it has an Instagram logo, maybe for sharing the article. The motivation of our work is, can we combine the merits of screenshot-based solutions and logo-based solutions? Here are the 4 contributions of our work. First, we systematically analyze brand intention plus credential taking intention for phishing detection. Secondly, we combine static and dynamic analysis to infer and confirm brand intention and credential taking intention of a web page. We conduct extensive experiments to evaluate phishing intention to show its effectiveness, robustness, and usefulness in practice. We implement phishing intention along with a phishing monitoring system and observe that phishing intention can report zero-day phishing with the highest precision in comparison to all baselines. We start with our work with an empirical study. We collect 30K phishing web pages from OpenPhish, and we find that 86% of them requires credential information immediately, and 11% of them are not a credential requiring page immediately, but it's one level adjacent to a credential requiring page. Thus, we think credential taking intention is important indicator for phishing detection. So we combine brand intention and credential taking intention to catch the one level adjacent credential taking page. We use static plus dynamic analysis. Thus, we include more comprehensive intentions while not introducing additional noises because we specifically focus on credential taking intention. This is the overall approach design. The first step is, given a web page screenshot, we extract the abstract web page layout. This AWL detector will report the salient elements in the web page. Step 2 is, we compare the logo against a set of reference logos. Step 3 is credential taking intention. We classify the web page as a CRP or non-CRP. CRP stands for credential requiring page, based on its abstract web page layout as well as the screenshot. Step 4 is, if the previous step classifies as a non-CRP, we try to see whether clicking some button can redirect us to a CRP. If yes, then we repeat the previous steps on the new page. Last, if logo gets a match and it's a CRP or one level adjacent to a CRP page, we report it as a phishing, as well as its phishing target. Now we'll have a second scan of our approach, but this time I will introduce more details for each step. For step 1, AWI detector, there are mainly two challenges. If we do element detection based on HTML heuristics, HTML can have flexible design. I can use different tags to implement the same element. I can also use JavaScript to pop up the element. Second challenge is we need to define which set of elements are considered as important to web page layouts. Corresponding to each challenge, we have two solutions. First one is we use object detection computer vision approach to report the salient elements. And secondly, we define 5 types of elements we are interested: logo, button, input box, text label, and block. This is an example output from AWI detector. Second step is brand intention. The challenge is that logo can have various types. Some are text-based, some are icon-based, or even both. Thus, to encode both shape-based features and appearance-based features, we propose a two-way image encoding network. The first branch is the normal ResNet backbone to encode appearance-based embedding. Second branch is OCR pre-trained encoder. OCR stands for Optical Character Recognition. Its task is to recognize characters in strict sense. So it's naturally trained to favor shape embedding instead of appearance embedding. Then we concatenate the two-way embedding as a unified one and project it to the final logo embedding. The third step is Crp classification. The challenge is that if we use HTML to identify the credential taking form, there are also different ways to implement the form. Some will use the normal form tag, but some can also use div tag, block tag, or table tag, etc. So we use a deep classification to classify whether it's a CRP or not. Also, black box AI model lacks an explanation, so we use model attribution as an explanation tool to explain why the model makes such a decision. So this is the design for our CRP classifier. We first concatenate the screenshot and abstract web page layout channel-wise, then feed it into a ResNet 50, which will output a binary label whether it's a CRP or non-CRP. Then for the model attribution technique, we use ScoreCam. It will highlight the most influential region to the prediction. So the heated region is highlighted here. That's why the model thinks it's a credential taking page. It's also conformed to our human decision because here are two credential taking input boxes. For the non-CRP to CRP transition, we need to click some login related or sign up related button here to transit to a CRP page. In some cases, we can find the login sign up keywords in HTML, but sometimes the features can also use icon to indicate such a CRP transition intention. So our solution is HTML plus computer vision hybrid transition locator. Step 1 is we search for clickable DOM element in HTML that matches to any of the keyword heuristics. In total, we collected 50 keyword heuristics. If step 1 fails, then we resort to visual object detector to detect the login button. So here's an example. This is the Amazon page, and the CRP transition button is centered here. And yeah, this is the last step. The last step is to report the phishing and the phishing target. For our experimental design, in total, we would like to answer 5 research questions. Due to a time limit, I will only cover RQ1, RQ4, and RQ5. RQ1 is a phishing detection experiment to test our performance against the baseline. RQ4 is to check the robustness of our system. RQ5 is to catch phishing in the wild. For RQ1, we have 25K phishing from OpenFish, plus 25K benign from Alexa. Our evaluation metric is ROC. ROC is a curve which plot the true positive rate versus false positive rate against different thresholds. The higher the ROC, the better. So we can see ours and our previous work significantly outperform the baselines, and ours is better than our previous work. For the robustness experiment, we introduce 3 kinds of adversaries. The first one is we use misleading legitimate webpage as an adversary. We collect 3K misleading legitimate webpage based on any of the 3 conditions. First one is they have sharing buttons of social media brands, or they have sign-in or registration via Facebook or Google, or they have embedded advertisement of Amazon or Microsoft, etc. So this dataset is aiming to compromise logo-based solution, but because we introduced the additional credential taking solution, so our system should be robust to this kind of adversary. Second type of adversary is HTML obfuscation as adversary. There are 2 types of obfuscation. First one is inside the HTML, we replace the login with login, this kind of thing. Second type is URL obfuscation, that will replace the login related keywords in URLs linking to the CRP. Because our system has computer vision part, so the performance should be largely preserved against HTML obfuscation attack. Third type of attack is deep learning model adversary. For the classifier, in total we have 5 gradient-based adversary attack methods. For object detector, we use a technique called DAG. All of them are gradient-based attack, specifically targeting for deep learning models. So this is the false positive rate on misleading legitimacy dataset. We can see that the 4 baselines all have high false positive rates on the misleading legitimacy, especially for those that are purely based on logo, like PhishZoo and Phishpedia. However, our solution only has 5% false positive rate. As for the HTML and URL obfuscation, we evaluate the classification accuracy before and after obfuscation for CRP classifier and completeness for CRP transition locator. We compare our solution against Xdriver. Xdriver is a baseline approach which detects credential taking form and CRP transition URL by HTML keywords. You can see even before the attack, Xdriver is worse than phishing intention. After the attack, Xdriver performance significantly dropped, but phishing intention can largely preserve its performance. For the deep learning model adversary, we evaluate the classification accuracy, or MAP. MAP is a performance evaluation metric widely used in object detection. We equip the deep learning models with gradient masking technique to defend against adversary. You can see without defense, the performance significantly drop, but after defense, we can preserve the performance. The last experiment is to detect phishing in the wild. We deploy a fish discovery system. First, we have a crawler to crawl URLs from CertStream. CertStream is a service to give feed for newly registered domains every day. Then we store all the web pages in a database and feed into 5 solutions. 5 solutions will report the suspicious URLs to a Telegram service where we have human to annotate the results and confirm whether it's a true positive or false positive. The evaluation metrics here are: first, we compute the number of real phishing divided by the number of reported phishing. Second is we count the number of zero-day phishing that is not reported by VerisTotal. VerisTotal is a collection of blacklist-based engines. In total, it has 89 different engines, and Google Safe Browsing is one of them. We run the fish discovery experiment for 2 months, starting from April 2021. We find that phishing intention reports 1942 real phishing, where 1368 are zero-day phishing that is not reported by any other engine. We also look at the precision by looking at how many real phishing are inside the top 1K reported phishing. We can see that phishing intention has the highest precision. We have one interesting observation is that we look at the distribution of brands of discovered phishing web pages. We can find that the distribution is heavily red-tailed. The top 5 brands are Microsoft, Facebook, HSBC, Amazon, and Instagram. So here I will reemphasize the contributions of our framework. We use more comprehensive intention, including both brand intention and credential taking intention to catch the phishing. Secondly, we combine static and dynamic analysis. Thirdly, we evaluate effectiveness, robustness, and usefulness. And lastly, we find that phishing intention can report zero-day phishing with the highest precision. There are mainly 2 limitations of this work. First one is we also observe there are some phishing web page requires more sophisticated interactions, like scanning a QR code or interacting with CAPTCHA. Secondly, our solution can only detect phishing that are targeting for brand inside our protected list. For brandless phishing or less popular targeted brand, we have no way to address that. Maybe later we will introduce behavioral intention to catch that portion of phishing as well. The last part of my presentation is to discuss my research framework in my PhD. In my research framework, I have in total 3 systems. The first system has 4 levels. First level is I have a sandbox where I interact with the malicious web page. Then I will extract the representation with AI techniques, such as web page representation and behavior representation. Based on the representation, I can infer the brand intention, credential taking intention, or behavior intention of the malicious web page. These intentions can be applied to various downstream tasks. Phishing web page is just one of them. We can also do malware web page detection, inappropriate content detection, etc. The system 1 aims for an explainable and transparent malicious web page detection framework. For system 2 and 3, system 3 will continuously collect new web pages and feed into system 1. After system 1 report the results, we will have a human verification and annotation steps where we can collect false positive or false negative. And these inaccurate cases will be fed into an active learning or online learning module to enhance the robustness of system 1. In summary, we would like to build an explainable, transparent, accurate, and robust malicious web page detection framework. That's all for my presentation. Thank you.
All right. So, by the way, So given the QA presentations is 25 minutes plus 5 or 30 minutes plus 10 minutes question answer.
Plus 15 minutes.
So 30 minutes plus 15 minutes question answer. So it seems that you have 30, I think you have 5 more minutes. You can, which means that you can elaborate more ideas during the presentations. And before I'm asking the question, so here, I hope that all of us try to have some attack style questions because so we're playing a role as professors and trying to attack the work and try to see whether the candidate is strong enough to defend her own argument. So anyone would like to have a try to play such kind of attacker first? Yeah, don't be shy. Just feel free to to attack. Yeah. So just raise the questions, and even it can even good to have some clarification questions.
Maybe I can start.
Sure, Dr. Xiaoyan.
Actually, one thing, the overview of the framework. Ruofan, can you go there? It's not question. It's just about the presentation, the total overview of the proposed technique. I remember you have several steps. Then you use the same you use the same, I mean the framework to talk about different steps. Because I'm not that familiar of this overview, so I suggest that maybe when you discuss one step, would you mind to except for the besides the, for example here 5, would you mind to highlight or maybe make this step, I mean bigger, because you like to use your your voice to present your words along with the words here. So maybe it's better to also highlight some parts of the figures.
Okay. Yeah, maybe I will highlight.
Probably to how did you feel? Because every time the image here, it didn't change, but there are some different words, I mean different steps here. I just feel a little bit strange because every time I want to check your overview, then but I also want to check your words, then it's hard.
2 minute words, so basically 2 minute words in this framework, right?
Yeah, because Ruofan likes use her mouse to I mean check the words. Then I will also along with her, but I don't have enough time to check the overview framework. This is about the pretension. Other thing, I'm not sure when you discuss about the runtime of the proposed technique.
I mean the runtime efficiency. So I mean maybe the first one is a comment, so you can clarify certain presentation, and the second question is more like what is runtime efficiency of this approach, right?
Yeah.
I forget the exact number.
I just wonder, because you have several.
Maybe I can rank the 5 approaches according to the runtime.
I think you have the time assumption, I mean evaluation in your paper, right?
Yeah.
But is it a research question or not a research question?
It comes after the phishing detection experiment.
Oh.
It's not a separate research question, maybe. As for the runtime efficiency, EMD and PhishSu are the slowest because they use some kind of traditional computer vision technique. And because all these 3 approaches are deep learning based. A visual fishnet is the fastest because it only have 1 deep learning models. Okay. And then the second fastest is Fishpedia because it doesn't have dynamic part. And the third fastest is Fish Intention. but the difference is not very large because not all web pages need the dynamic analysis. Usually they will, once it's a CRP page, then I don't need to run the CRP transition locator.
Okay, I see. Okay, I think, yeah, for me, now that's all. I will think if I have one, I will unmute again.
And anyone have other questions? So even it is good, you can even it's quite good if you even ask the clarification questions. Okay, seems yeah. Oh, okay, Kushit, please.
I just wanted to ask. I'm just curious. Can we use something like look and feel properties of web page? For example, we can zoom in and zoom out the web page and take several screenshots and maybe track the distances between different items in the screen, kind of thing. Yeah, I mean it may not use HTML, but sometimes such kind of properties also hint something. Yeah.
You may zoom in and zoom out. Then how do you detect the elements, this distance?
Well, if you have different screenshots of zoom in, zoom it out, and zoom it in web page, you will see that some items got far from each other, or some items get bigger in the same rate and others are not. Or maybe while going from one page to another page, the animation might be different, right, from the actual web page. So
yeah, you mean web page can have many dynamic elements.
Yeah.
If you just take one screenshot, then it might not be loaded. But if you somehow execute all the possible JavaScript, maybe you can take multiple versions of web page screenshot, and some of them might be useful for our phishing detection. Some of them might evade our phishing detection. So I think your suggestion is valuable. Maybe we can have multiple versions of web page screenshots, and when one of them reported as a phishing, we think this web page is phishing. Yeah, because I noticed that there are some work talking about the cloaking technique. So basically, the phishers will detect your agent. If they detect you are Google safe browsing, trying to catch them, then they will show you a different content. Maybe they will show you a benign content. But if they know that you are a normal user, and they will show the malicious content. So somehow we need to address these problems. But this is actually not the focus of this approach. In this approach, we assume that we already obtained the web page screenshot and there's no cloaking technique here. Yeah.
Yeah, cool. But yeah, interesting. Thank you.
Thank you.
Hey, Ruofan. So Khurshid raised a good question about the dynamic web page, and maybe I'm missing some details. But how did you crop with different page layouts? For example, the page length or the width, something like that. Because we know all the websites are definitely not in the same size, right?
Oh,
are
so
you choosing the first page as a screenshot, or you normalize it? Means how did you do that?
So I fixed my window size as a rectangle, maybe 1000 pixels times 1000 pixels. And then I scroll to the top. So if the page is long, then I only take the screenshot of the top portion, because usually that is where the logos and important buttons appear. So I will only focus on the top parts. Yeah.
Yeah. Okay. Yeah, that makes sense. Yeah. Thank you.
Any questions? Maybe Xiangling, Yufan, Mengyue, any questions? All right, so I think the question are all very nice questions. So I will try to play as a bad guy to ask some tough questions. The first question is that, so here, the phishing detections are largely relies on the reference, the title reference, right? A title list. So which means that if the website with this logo not in the title list, it is basically an unknown website, not necessarily a benign website. So in your approach, why do you believe it's benign website?
Because I have mentioned it in our limitation, because our protected list is limited. So it's not possible to catch all kinds of phishing in all brands. Maybe a possible solution is we keep the process URLs, and then we check them in various total after 1 week. And if the various total reported as a phishing, then we know that we missed this web page. So we might need to add this logo into our protected list. So our protected list is expanding. It's not like when it's set to be maybe include 200 brands and it's always there. We need to keep expanding our knowledge.
Okay, so in short, so as a defense answer argument, you're trying to say, this is our limit, and in the future work, you're trying to expand the title list during the evolution or during the runtime system monitoring, right?
Yes.
So now, so if I try to attack harder, so we're saying that, so I will ask the second questions. And how many companies and how many references are there in your target list?
There are 277 brands in our target list. So this brands is collected based on we have 6 months data. We have collected phishing from OpenFish in 6 months, and we include all the most frequently appeared brands in our target list. We also include the brands that appear in one of the baseline visual fishnet. So
all right. Okay,
yeah.
so in this case, since I'm trying to attack even harder a little bit, so just to a little bit prepared. So given that it seems that so all the unknown, I think all the unknown website has been reported as benign, right?
Yes.
So have you evaluated or measurement the false negative in the field study?
We haven't done that.
Which means that a lot of the non-website. So may I further ask the question is that since these approaches basically have a strong arguments for the false positive, which means they have very less positive, but the measurement of false negative is largely unvalidated.
Yes, but in this one, we care more about false positive because we believe it's okay to miss some phishing, but we wrongly report some benign as phishing that will compromise users' confidence in our solution. So we care more about precision over recall.
Yes, so the question is that you're good to saying that you have very good false positive, so that's what I understand. But I'm really concerned that why there's not even a measurement of false negative. Because the key question here is that all the unknown website have been reported as benign. So these kind of worrisome, don't agree with that? And why there's no measurement for the false negative? Yeah, you can take the question. So I just play a virtual attackers. So if you are, suppose one of your examiners is someone like Roland, and he would like to ask questions with sharp questions, and I think you need to be better prepared with that kind of questions. So So basically, I think if so just from my point of view, the answer, the better answer is that first, we do have evaluations on false negative on the Phishing PDS experiment, right? So we do have data. So in this case, you somehow need to show the data or the measurement of the false negative. And the second counter argument is that you somehow need to claim the target list will consumes the majority of the phishing website. So you can provide such arguments, which means that these logos actually take over a large number of phishing website, and a phishing website is supposed to be lucrative, profitable. So it didn't bother for the attackers. All the attackers do not bother to emit some unknown website because it's not lucrative and there's a cost for them to conduct the attack. So maybe that is a way to defend it. But anyway, so this is just one of the harder questions we're trying to make. But anyway, you're trying to, maybe you need to trying to prepare harder questions yourself. As long as you cannot defend it well, it's better to be well prepared because you need to give your response within 3 to 5 seconds. All right, so maybe this is just one of the questions. Second question is that maybe because I know the approach quite well, so I can raise another technical question. So what is runtime efficiency when you interact with the web page? So it is okay for the deep learning approach to predict the logos, buttons, form, etc. But when you're trying to interact with the web page, it will take much more time than the predictions. So it will cause some efficiency concern.
So to address the efficient concern, we set a timeout as 2 seconds. And we also limit, we only look at one level adjacent, so we limit the depth of CRP transition detection. We also find we only interact with the top 3 possible CRP transition link to limit the interaction time. So maximally for a web page, we visit 3 adjacent pages, and each one with timeout 2 seconds.
All right, so that is a way for us to save, but so somehow it would be better to just saying that each interactions, how long does it take for each interactions? Maybe 1 second, 2 seconds. The first argument I suggested you can claim that the effort spent on interaction is acceptable. Maybe you can just ask that, and you will say that it does include cost, but the cost is worthwhile. Somehow you can just make these kind of counter arguments, right? Yeah, so you can think about a lot of hard questions and the reviewers' questions, or especially the unaddressed reviewers' questions. So that is also what you can project the presentation. Yeah. Anyway, so during the QE, you should always try to defend. So, but not over defend yourself, but try your best to find the key point of questions and try to provide a logical and justified explanations to address the concerns. Yeah, and never counter or argue with the reviewers or examiners too much. So if you really find hard to address it, you just say, leave it to the future work. All right, so I just raised a few questions if you take notes, so I can start with my comments. So my first comment is that overall, the presentation is very hard. I'm not sure the word very hard is appropriate, but I feel that a lot of students cannot easily follow. So this is my gut feelings. Maybe there's time limit. So first is there's a lot of words, just like Dr. Xiaoyan mentioned, there's a lot of words, even in the framework, right? Even in the graph. So here.
But if I do not put words there, I will forget what I should say.
you just write lines. Xiangling write a lot of lines there. Right.
But this picture I cannot change the text. I just
okay. I will be back to this. I'll be back to this graph later. So maybe I can go through the slides one by one. I just go through my notes. First, would you please go to the slide 5? First, I think my first comment is good that you use 2 USENIX paper to back up yourself. So if I'm the examiners, I see you have 2 USENIX papers in your publication list. I will try to refrain a lot of my questions and suspicions, which means that this work have gone through very thorough examinations from the top tier security experts. Despite that, I will still try to. I cannot help but to raise a lot of questions based on your presentations because there are too many words here. So the first suggestion that you try to remove as many words and turn these words into pictures. As a human intuitions, pictures is much more friendly than words. So I started my notes one by one. The first is that here, I suggest you borrow an animations. So there's a lot of links there and 1, 2, 3, 4, 5, right? You just show the links 1 and remove the rest of the links. And then second, you keep the link 1 and show the link 2, and animations will make it more, I think will be more helpful, right? So this is basically tell the audience how the phishing attackers are going to play the games here, okay? And the second is about the related work. And for the related work, I think it is kind of, maybe you can just say it is state-of-the-art work. Yeah, I understand if you write a paper, we can call it related work. But usually, but if it is storytelling style, we somehow call it how existing solutions address the problem, right? And also, again, I suggest that do not use the words here. You just showing here, we have a blacklist, right? You can just have a picture of what is a blacklist. And somehow we check one by one, or just showing a typical example of blacklist solution, like Google Safe Browsing, right? So a lot of people on their visits has been blocked by Google Safe Browsings, by Chrome. So people will have a more intuitive understandings, what is kind of best the backlist-based solutions. And sometimes, I think a lot of us will ignore the warning of the Chrome and the Google Safe Browsings to keep going on. So which means that the solution is not satisfying, right? So you just try to interact with people, and you can ask questions. How many of you have ignored the warnings for Chrome and keep visiting the web pages? So whether this blacklist-based approach is reliable. And second, you can introduce that this blacklist is kind of outdated because phishing website can always emerge every day. And you can also show a picture of how attackers automatically generate phishing web pages, right? You can see, which means that blacklist solution is not good.
But do you think Chinese should keep this blacklist-based solution? Because for Google Safe Browsing, how they detect phishing, I think they also use some automated algorithm.
They will have some automated algorithms, but the blacklist is also a very important access component of their approach.
Then can I just remove it and just say classification-based solution?
I think the blacklist is also, because blacklist approach is industry level solution. So I think you can mention this, I think no worries. And also blacklist is you just go through the history. And for classification-based approach, I think no need to spend too much time here. It is also well known that the feature engineering is kind of problematic. And also you can show that it is not explainable, right?
It's actually more explainable than deep learning-based solutions.
No, classification will just provide a yes or no, right? So 0.8, it's 80% of the probability of being phishing. Why? There's no explanation.
If you have a decision tree, you know how the decisions are made.
Yeah, it is where how we can have a decision tree, but we are not guaranteed to have a decision tree, right? We can have a deep learning. We can have SVM, right? So that's all possible. So the explanation is not general. And also, of course, you can say it's vulnerable. And the feature engineerings it's very easy to evade, right? So you can just mention this. So anyway, my suggestion is that you just showing a few pictures or examples of what is blacklist solution, what is classification-based approach. Okay, so and this is suggestions. So maybe we can move on to the next slide. And yeah, here, I think the reference approach, it is okay here. But why I have concern here, because we have 2 USENIX paper, right? But in this work, you just introduce one. And the Phishpedia is basically a baseline. So I just want to ask, what's your consideration to not present Phishpedia, but just use Phishpedia as a baseline?
Because if I want to present my second work, I have to criticize my first work.
I think anyway, so making this improvement or make this adjustment will involve a lot of efforts, but you can consider this. We can first criticize Visualfish, NetFish, Sony EMD to saying their problems. And in the second work, you're just saying that Phishpedia is not enough because logo can only, so the efforts or the contribution of Phishpedia is that we provide an efficient and precise solutions to detect logo, right? So this is the basic idea.
Phishpedia.
Yeah, for Phishpedias. But in the second one, you just introduce how we do this, because there's a lot of we have a false negative measurement for Phishpedia. And in the second work, you can just say that after we work on the Phishpedia, we realize that the logo can only convey partial brand intention or partial web page intention, right? So we, based on the Phishpedias, we have a second work. So in this way, we can remove a few details of the experiment. So I think people will more likely to look into approach, and for experiment, I think we would rather let them to go through the paper instead of go through a lot of technical details. So you can consider these. So in your presentations, you do not claim one contribution, you claim 2 contributions, and the second one is actually built upon the first one. A minor problem is that when you are showing your presentations, is that possible that showing a full screen mode instead of, because I can see your browser, right? I can see your browser. You can see maybe there's a short key there to show your presentation in your full screen mode instead of just inside the browser. Okay, so the next one is going to slide 18. Yeah, so here is still trying to, I think this is just a race example of the need of examples. So because all of these, you have a lot of words, right? So for the first categories, it requires credentials. What kind of web page require credentials? And you say one level adjacencies, you somehow saying that what kind of web page looks like a one level adjacency of the phishing web page, right? And it requires special credentials. So what web page requires special credentials? So you just raise examples, which makes the audience more intuitive, so that people will understand more of the research. And also slide 12, sorry, the 1222. Right here. So followed with Dr. Xiaoyan's suggestions. So here, this approach, I think I draw this framework in our paper. And the major reason is that we would like to squeeze as much information into the papers. But in the form of the paper presentations or just demonstrations, my suggestion is that we use a real world web pages instead of this screenshot. For example, in the first step, right, we have a web page screenshot, and from the very beginnings, we have a web page screenshot. And after the first step, we will recognize the logos, buttons, blocks, input, etc. So we call this one as an abstract layout. So just showing a real and a concrete example. And in your after second step, you are trying to detect where the logo, right? You're trying to find the logo and detect the brand intention. So for example, you can showing that given a concrete example like PayPal's or like the Microsoft, and we find that in the web pages, there's the Microsoft logo just showing that we found this logo, and after second step, we know this logo is Microsoft, right? No need for the user to understand the technical details, but they know that what's the input and output. And after your logo was generated, if this logo, we can find these web pages actually credential takings, we say that it is phishing. If not, we try to find the login button or sign up buttons to see what is logo. Oh, sorry, whether it's phishing, right? So based on these concrete examples, there's no need to say there's so many steps. You just use animations and guide the user in a stepwise manner to understand how the approach really works. Because overflow is really straightforward. It will have only one. It has only two branches. One branch, we can detect the credential taking intentions. The second branch is we cannot detect the credential taking branch. Credential taking intentions, and that's all. Right. So in summary, we show concrete examples instead of abstract step. And for the so the next comment is on the experiment. So on the experiment, it's good that we should, basically the idea is that you tell the audience, tell the examiner that, right? So giving so many approach design, so many technical details, our approach is the best. So you would like to convey the best, and of course you did a good job to convey this one. But you know that just as we have a discussion with Dr. Xiaoyan saying, so the researchers will always be able to make their results good. Otherwise, there's no publication, right? So in this case, if I'm the audience, I would really want to know what is the limitations in your experiment. For example, you can raise a few qualitative example. For example, what kind of approach? Our approach is better than the others. So we have a lot of qualitative examples there, right? I think you can put this example and let the reviewer and let the audience to see and how phishing intention, phish PDS can outperform the rest approach. So here, results and data is all theirs, and no one will question this data statistics, but people will look into the example to have more feelings about this approach.
But I only have 30 minutes.
Yes, you have 30 minutes. So I think I suggest that you reduce some of the introductions of the experiment. For example, let me see your question, RQ1. Right. So
my introduction is only 2 points.
So you can just saying that. So maybe you don't need to say the first part. You're just saying that you can just put the 50K websites besides, and you can there's just one slide for the RQ1, but you provide more examples. So let me see RQ4.
RQ4, I need to introduce a lot.
Yeah, I think RQ4, I'm not sure it is we really further need to introduce RQ4. So maybe my suggestion is that, so if we're writing a paper, we have RQ2, 3, 4 to avoid the reviewers' questions. But in the presentation, I think we only need RQ1 and RQ5. The experimental statistics or the in-house experiment and the field study. And that too is enough. And for the adversaries, I suggest we remove them. And also there's a lot of words in the adversaries. So I feel given the time limitations, we need to go through all the points. I think it's very hard for the audience to fully digest all these adversary. Right. So, and also we can remove these other results, which save a lot of time.
But I thought in security, they always ask, what is your adversary? What is your adversary?
Then you prepare the slice, use it as a backup slice.
Okay.
But I'm worried because Ruofan still have 5 more minutes. If also shorten this part, then which part?
Yeah, I think yeah. So we provide examples. Maybe we provide the example of the false positive, example of the false negative, example of the true positive in our work, but a false positive in other baselines. So we show these examples. So we can have more intuitive answers. And also, if possible, so we can introduce a little bit about the Phishpedia. And because this is our first work, so I think there's enough time for that. Okay, so now comes to the last comments about your conclusion. So yeah, I think I have no comments on your research framework. So it is good as we discussed. So my question is conclusion is still contain too many words.
Conclusion.
Yeah, conclusion.
This is my conclusion.
No. This is your research framework. Your conclusion is yeah. The next slide. Yeah, this is the conclusions. So my suggestion is that you shorten the sentence into a phrase, into a short phrase. So here you can saying that this is our approach is intention based. So maybe if I were you, I would say our approach is intention based. So we have 2 smaller bullet, brand intention, credential intention, and then you try to speak and organize the sentence your own way on the fly. And the second is that the technical is static and dynamic, right? So we just remove the sentence. We just show the face. Yeah. So if possible, I'm not sure whether the time allows, we can also have some demonstration. So given a screenshot, given a website, and you just input efficient web pages, you just demonstrate how the explanation is generated. So maybe if not possible, you're just showing a screenshot of Phishpedia. That is also possible.
Screenshot of Phishpedia.
Yeah. So my suggestion is that Phishpedia is not just your baseline. It is a baseline of fish intention, but Phishpedia is also your contribution. Why not claim it? Right. So you're saying 2 papers, but basically you're just introducing 1 paper.
Because I think I don't have time to go.
Yes, you're right. You don't have all the times, but definitely you can briefly go through how Phishpedia looks like.
But here in the related work, I have already go through.
Yeah, my suggestion is that you take more time and efforts to introduce this our work, and it just means that this is a USENIX maybe last year. So just mention this and what it looks like, right? And just showing that, I think take 5 minutes, it's okay to introduce Phishpedias and how it looks like and how it outperformed the others and why we need another work to further improve Phishpedia. So you just have this kind of storyline.
So here I say why, but I combine Phishing and Phishpedia together.
That is okay. So that's when you start with the introduction of fish intention, right? So, but my point is that you claim Phishpedia is a contribution instead of just to let it serve as a baseline. Yeah, I think that's all my comments. Yeah, but anyway, back up with 2 USENIX papers. So very hard. Reviewers or examiners are really hard to block you. But I think that is a very good opportunity to organize your storyline. Yeah, if you need, we can organize another rehearsals if your slides were prepared. All right, so I think, please.
I think Ruofan don't just delete the some I mean the experimental parts. I mean the slides. You can make the slides in the
backup slides, right?
Yeah, because I remember if others ask you, for example, ask you at virtual, if you don't have time, but you can, if others ask, you can just go to that slide and go on explanation. Yeah, in case another research question, in case they ask, you can also make backup slides.
And also my suggestion is that you will have an index of research question 1 to research question 5, right? So when you do the presentations, this is what how do we write a paper? And when you do the presentations, you're just showing that in-house experiment and field study. So that is just enough. And of course, if there's a reviewer or examiners with security background, so they will definitely ask what is a tech model and what is adversary, what is your adversary. So then, just as mentioned by Dr. Xiaoyan, you say, you just go through the backup slides, saying that this is how we address and assume the supposed adversaries. All right, so I think that's all for Ruofan's qualified examination presentations. Is there any questions? And especially Yufan, I assume that you will have your own QE presentations in a few months.
No more questions. Thank you.
All right. So since there's no more questions, maybe you can call it a day for today's meeting. Thanks, everyone. Bye.